Hi, myself Dr. Kumaran. Today we will discuss about microcontroller. The term microcontroller. Already you might have some knowledge about microprocessor. So in that aspect, I am starting this course, microcontroller. Let's have an introduction for this. Microprocessor based system. So whenever we use a microprocessor to develop a basic application, for example, 8085 microprocessor. Uh, Suppose we want to design a system, we need to have memory for storing our program, then data we need to handle. For that we need random access memory, read only memory. Suppose we have some input output switches, led, then we need IO port. IO port in the sense how we are going to connect input and output devices to the microprocessor. Some application we need a timer. A timer in the sense uh, some task we need to trigger based on time interval. For example, AC we are setting up on time, off time, then how much temperature, everything we are setting up, isn't it? So in between a circuit has to count the time interval, then only the events can be happened, isn't it? So for that we need a timer circuit. Then we need to have a communication port, communication interface, because whatever the data which is processed in the microprocessor has to communicate to the external world. Then from external world we need to download the into the microprocessor. So for that case we need to have a mechanism through which the microprocessor will communicate to the external world. So these are all the basic peripherals needed to develop a microprocessor based system. So the microprocessor IC, then RAM, ROM, IO port, timer, serial port, these are all minimum peripherals. So likewise, many devices we are connecting in with the microprocessor, then only we can develop a basic system for an application. So this is called microprocessor based system. So when we have large number of ICs, then possibility of any one IC, one pin is broken or any malfunction, there is a probability the failure of system is higher. So that's the issue here. That's why we are going for the concept of a microcontroller. So before going into the microcontroller, we will have a practical example what is microcontroller. For example, university. University means it has a lot of courses, isn't it? It will have engineering course, arts, then medical courses like MBBS, BDS. Then we have media courses, which will editing, direction, photography. Then we have law courses, Bachelor of Law, Master of Law. Then we have diploma courses, certificate courses, then PhD research courses. So all are available in a particular institution that is called university, isn't it? That's what we are studying in our courses. When it comes to that microcontroller, we need to have microcontroller means it will have a microprocessor. Microprocessor, then it will have IO devices, ADC, DAC, RAM, ROM, timer, a serial port, interrupt. All the devices are connected in a single IC, which is called microcontroller. So from the outset, you can imagine that the microcontroller means it will have a microprocessor. Additionally, it will have peripherals. The basic peripherals needed to design a system, then the microcontroller is designed actually. So then you can have a doubt. So the microcontroller is the best compared to the microprocessor because it has a microprocessor, then additional peripherals. So that's it is not true, because microprocessor is designed to handle large amount of data at very high speed. That is called microprocessor. So the speed of the microprocessor is very high. It can handle the large amount because the size of the microprocessor is latest we have i9 processor which is 64-bit. But the microcontroller we have very simple CPU, because the micro intention of the microcontroller is not to have uh, high data processing. It is intended to device control applications. For example, a washing machine controller. In washing machine, what are the devices we have? We have input switches, then motor, we have inlet, water outlet, then detergent inlet. So these controls, few controls are there. So we need a timer, we need memory. So in that case, the microcontroller is enough, because in my washing machine, the program size is hardly that 2K. 2 kilobytes, that's it. So for that, the microcontroller is enough. The additional peripherals also will support, then the device will be performed. So likewise, wherever we are going for device control applications, then we'll choose microcontroller, because the peripherals needed for device control is accommodated in the microcontroller. But microprocessor, we go with general purpose computing. For example, a powerful computer, laptop, for high data processing, like radar control. Those applications we use the microprocessor. Still, between microprocessor and microprocessor is a powerful device. A microcontroller is less. It is a small compared to the processing capability. Compared to a microprocessor, controller is smaller, but will have additional peripherals. It is enough to perform a device control application. That is what microcontroller. So 8051 microcontroller, let's start the pin diagram, which is a 8-bit microcontroller. So its CPU size of 8051 is 8-bit microcontroller, which has a 40 pin dual inline package, same as 85, 86 a microprocessor like. So 40 pins. In that, most of the pins are multifunctional. So the same pin will act as 2 different or 3 different functions. That is multifunctionality of the pin. So in the definition itself, we have seen that microcontroller have I/O ports. So in 8051, we have 4 I/O ports: port 0, port 1, port 2, port 3. All are 8-bit wide. So totally 32 I/O lines are available. Each and every pin we can configure either input or output. Suppose you want to use the port pin as an input, we need to write logic 1 on the port SFR latch, port special function register inside, available for each and every pin of the port. So 32 latches are available to configure the port as an input. We need to write logic 1 on the SFR latch, then the port will act as an input. Output means directly you can write the data, the pin will act as an output. That is. Then apart from the I/O functions, the port 0 is used as a lower order address and data bus. Even though the 8051 has internal memory, suppose we need to have external memory, that time it's possible to have 16 address lines, 8 data lines. The lower order address and data lines are multiplexed with P0, AD0 to AD7, which can be demultiplexed with the help of that address latch enable ALE. So through that we can demultiplex, separate address and data, separate we can with the help of ALE. Then the port 2 is I/O function, then the higher order address bus A8 to A15. That's it. Then the port 1 is dedicated for I/O, input and output only. There is no multiple functionality. The port 3 will have alternate input output apart from the general purpose I/O. We have TXT, RXT for serial ports. Then the 2 external interrupts, INT0, INT1. 2 timer interrupts, T0, T1. Through that, the clock will be given as an input, which will be counted by the internal timer. Then the read-write control signals to access external memory or I/O device. Then we have 2 crystal pins, XL1, XL2. The 8051 will support that up to 20 megahertz crystal. So here the 8051 has internal clock divider. Suppose we are connecting a 12 megahertz crystal here, that will divide this by 12. The 1 megahertz will be the operating frequency. Then the ground and power supply, it is a plus 5 volt is enough, because it's a TTL device, transistor logic. So plus 5 volt is enough to operate the device. Then there is a reset. You know that reset means whenever we are enable the reset pin, the microcontroller will erase all the internal RAM. It will start from the first memory location. That is a reset. Then we have a external access. External access means you know that 8051 have internal memory. We can connect external also. So whenever we are using external memory from first memory location itself, it should be connected that ground, which means that if you are connecting ground here, then the microcontroller will fetch all the programs from external memory through the address and data lines. That is external access. Program store enable will be used as enable pin for the external data memory. Externally, we can connect program memory as well as data memory. That's all about the 8051 pin diagram. Let's move on to the futures. It's a 8-bit CPU which have on-chip clock oscillator. The external crystal we need to connect. The internal circuit will configure the operating frequency. Then it has 4 kilobytes of program memory. So that's the program memory size, which is more than enough for any practical applications like our refrigeration, AC, washing machine, smart TV. Like many devices, the 4K program memory size is more than enough. Then 128 bytes of RAM for the data handling while writing program, that is 128. Then the external memory we can connect 64 KB of program memory, 64 KB of data memory. So both are possible here. Even though it supports internal RAM ROM, we can connect externally also if it is needed. Then we have 32 bidirectional I/O lines, which are organized as 4 I/O ports, each 8-bit wide. All are bidirectional. We can configure either input or output. Input means we need to write logic 1 on the port bus or latch. Then we have two timers, two timer counter, 16-bit. The word timer counter will have different names, but functionally the same. Only the clock input, if it is taking internal clock, which is called a timer. Suppose we are giving a clock input from external T0, T1, then that circuit is called counter. Functionally no difference, only the source of clock is differs. One serial port through which we can communicate external device RxT, TXT. We have a universal asynchronous receiver transmitter. So it's possible both synchronous and asynchronous, actually USART. Then 5 source of interrupts it will support, 2 external interrupts, 2 timer interrupts, 1 from serial communication. That's all about the features of 8051 microcontroller. The block diagram of 8051, as we have seen that features, we have a 8-bit CPU, will perform that 8-bit arithmetic and logic functions, which has registers and clock register also inside that. Then we have an oscillator circuit, which is clock divider divided by 12. Whatever the oscillator we are connecting external crystal, that will be divided by 12, then that will be the operating frequency of the entire device. Then we have 4 I/O ports, namely P1, P2, P3, P0. All are for 8-bit bidirectional I/O. Then we have a serial port TXT, RxT, through which the data will be transmitted externally, from external to internal, internal to external. Both is possible here. Then we have a 2 timer. Both are 16-bit wide. It will count the number of clock pulse given to here. So 16-bit means it will count that 2 power 16. 65, 536 clocks it will count. Then 128 bytes of RAM for data handling, 4 kilobytes of ROM for program storage. Then we have an interrupt control circuit, which is 2 external interrupts, 2 from timer interrupts, 1 from serial port interrupts. That's about a brief introduction of 8051. In this series, we will move on one by one each and every block. For example, timer means we will have one separate class, serial port one class, I/O port. Likewise, we will discuss each and every block of the microcontroller one by one. Then we will start that programming also, both in assembly as well as C language. Yeah, if you have any doubt and clarification, you can comment on the comment section. I will clarify. It's always open to discuss anything regarding this topic. Thank you.